Hello Year 11 and welcome to our fourth video here for our first topic, formulas and equations. Now we're going to be solving equations today. Before we do that, let's just skip back quickly and review what we've done so far. Right, 3 videos in there. First one, we simplified expressions, collecting like terms, multiplying and dividing them. We made, so we did that to make our expressions simpler, fewer terms generally speaking. In our second video here, and our second exercise, 202, we expanded expressions by getting rid of grouping symbols like brackets. Okay, we use the distributive law, we multiply what's outside the brackets by what's inside the brackets, and then we might combine that with our skill from that first video too, where we expand and then we simplify, okay? So maybe we ended up with sort of lots of terms and then we combine them again to simplify, okay, but without any brackets. In our third video and exercise, we looked at formulas, right? Evaluating a formula by substituting, that is to replace some unknown pronumeral with a known value, with some sort of number. Okay, we put those in to play our order of operations and arrive at some number. All very good. Now we move in a slightly different direction here with solving equations. More challenging, I suppose, more rewarding as well. While in very, very many questions during this course you will evaluate a formula, and you won't solve equations so frequently, but it's more likely to be a standalone sort of question. Question will just say, solve this equation. Okay, some of them quite straightforward, some of them much more challenging. As I said, they can be quite enjoyable if you get in the knack of doing them and you sort of think of creative ways of getting there or efficient ways of getting there. The main thing to remember here when we're solving equations is an equation means the left-hand side is equal to the right-hand side. So, for that to continue to be true, if you should make a change to the left-hand side, you have to make the same change to the right-hand side. And that's essentially what we do. We make consistent changes to the left and right-hand side in such a way that we end up with an equation that says x equals some number, or something along that pattern. Okay, I'll show you how that works here. I'm sure you've done these before again, but nonetheless, here we go. 3x minus 4 equals negative 13. What am I going to do here? Well, first thing I'm going to do is I'm going to add 4 to both sides. I don't like doing these little subscripts very much, but some people find them helpful, and I'll just do them every now and again, just for the benefit of those people that like it. So here we go. I know that if I've got a minus 4 and a plus 4, it just becomes 0. I don't need to write that. So on the left-hand side here, I have 3x. On the left hand side, and over on the right hand side here, negative 13 plus 4, right? Negative 13, advance sort of 4 spaces to the right along the number line, will bring us up to negative 9. All good? So 3x is equal to negative 9. Now I'm going to divide both sides by 3, so we can do this. As I said, I don't particularly like this sort of notation, but you know, here we go, just for the first one here today. Now 3x divided by 3 is just 1x, which we write as x, and that tells me that I'm mightily close to a solution here. Negative 9 divided by 3 is negative 3. So there's my answer of x equals negative 3, and that's perfectly fine to leave your answer there. If you have time and the inclination, you may wish to check your answer here. And the great thing about solving equations is typically they're very easy to check. They might be hard to solve, but easy to check. And we do that by substituting our answer back into the original equation. So my left-hand side, as I said, don't have to do this every time, but here we go. My left-hand side in this case is going to be 3 times, I'm going to put a bracket here, negative 3. 3 by negative 3 minus 4, which is equal to, 3 times negative 3 is negative 9. Negative 9 minus 4 is negative 13, which I can see is equal to my right hand side. So there we go, I have a valid solution. Rightio, all good. Well, let's move along to the next one here, which is a little bit trickier. It's got a fraction in it. There's more than one way we'd go about doing this, but I'm going to do it like this, right? Fractions can be a nuisance, so I'm going to get rid of it by multiplying absolutely everything there by 2. So b over 2 times 2, that means half of b times 2, 2 halves is 1, I get b. Plus, now 2 lots of 7 is 14, equals 2. Okay, I have taken every term in that equation and doubled it. And that looks a bit more familiar now. In fact, that's looking pretty nice, because what I'm going to do now is subtract 14 from both sides, or if you like, move this 14 to the other side and make it a negative. I'm going to subtract 14 from both sides, and I'm going to end up with my solution. Therefore, b equals 2 minus 14. Therefore, b equals negative 12. Oh, yeah, that's pretty good. Now, I'm going to do my check here just in my head. I'm not going to write it down with this left-hand side, right-hand side stuff. But just quickly, to satisfy myself that this is okay, I have negative 12 divided by 2 is negative 6. Negative 6 plus 7 is 1. That looks good to me. I'm pretty confident. I'm ready to move on to the next, and what I think is probably the last example here for this video. So, once again, we have a fraction. I don't have variables on both sides, you know. Maybe that's a bit of a shortfall here with these notes here, because you get some of those. There's all sorts of equations you might be asked to solve, but ones with fractions often bring up some difficulties. So I'm going to follow the same pattern as before with the fraction here. I'm going to multiply everything by 4. Just be careful, however, that this essentially has brackets around it, this h minus 10. So when I multiply all of this by 4, it will cancel the 4 from underneath. And remember, the 4 is underneath both of those things there. So when I multiply all of this by 4, 4 cancels out, and I'm left with h minus 10. Okay, that's h minus 10 equals 3 4s are 12. Rightio? Now, another way of thinking of doing this is you could bring the 4 up to this side here. Right, from the bottom to the top. You don't change the sign, you just move from the bottom to the top, or the top to the bottom. Perhaps you've learned to do it that way, and that's perfectly fine. Okay, but sort of in simplest mathematical terms, I think we multiply everything by 4, and this is essentially a quarter of h minus 10. So 4 lots of that is just h minus 10, and 4 lots of 3 is 12. Now from here, add 10 to both sides, and I get h is 12 plus 10, and h equals 22. Quick check here just in my head again. 22 minus 10 is 12. 12 divided by 4 is 3. Good with the answer there. Now there are usually multiple approaches that you can take that will correctly solve these equations. Okay, there are often different things you could do. And don't fret if you've used a different method and got the right answer. Now, sometimes it's possible to get the right answer by doing the wrong thing. It's called a howler. Sometimes you get the right answer by doing the wrong thing, and that's sort of an accident, a fortunate accident. But generally speaking, just because you haven't done it exactly the same way as me doesn't mean that you've done it wrong. If there is some doubt or confusion, though, please check with me in class. That's what all our class time is there for. Okay, hope you enjoyed it. See you in class.